Hey everybody, let's look at this problem from 1982. We got a rope pulling something up, what I call generically an elevator problem here. And so it says a crane is used to hoist a mass M1, here's M1, of 500 kilograms. And this has got T1 as the cable that connects that, the lower cable. The load is suspended by a cable from a hook of mass M2 is 50 kilograms. We can see that right there. And the upper cable is what they're calling T2 there. The load is lifted upward at constant acceleration of 2 meters per second squared. So first off, let's do some free body diagrams on these. The load off of here has a force of gravity on it, like that. And then we also have a tension on it. That's tension 1 connects to the load. This tension's got to be bigger than this force of gravity because it's accelerating upwards, so the upward force wins. Now, of Newton's third law pair, if the hook pulls up on the load with T1, then the load pulls down on the hook also with T1 there. The hook will also have its own little force of gravity as well, and then we will need a tension 2 that's bigger than those two put together, because the upward force has to be winning in order to accelerate that hook upwards. All right, now let's go and find here the tension 1 in the lower cable and the tension 2 in the upper cable. And remember, we're accelerating at 2 meters per second squared upwards. So on these, let's start with our Newton's second law. The sum of the forces in the y direction is equal to the mass times the acceleration in the y direction here. I'm going to solve this generically, and then we'll plug the numbers in twice, once for the upper cable and once for the lower cable. So the sum of the forces in the y direction, we've got tension up minus the force of gravity down has got to be equal to the mass times the acceleration in the y direction. And then let's move the force of gravity to the other side. So the tension is equal to the force of gravity plus the mass times the acceleration in the y direction. And then last step, let's replace the force of gravity with what it is equal to, which is mass times the acceleration due to gravity. And there we wind up with the Frankenhoff equation. You can factor that m out if you want, or just leave it there. So now that we've got those, let's plug it in for T1. So T1 is going to equal the mass of the load, what they call M1 times G plus M1 times the acceleration in the y direction. So that's how we're going to set it up to solve. And now let's plug in. So T1 is equal to our mass for the load, they said, was 500 kilograms. The acceleration due to gravity is 10 meters per second squared. Once again, here we've got 500 kilograms as our mass, and the acceleration in the y direction is 2 meters per second squared. And so now when we do all the math for this, we will get that tension 1 is equal to 6,000 newtons. Now let's go and do this again, but for the upper cable here. Now be careful when you go to do it with the upper cable, because remember, this upper cable is pulling all of this mass. There's a mistake to want to just put in 50 kilograms, but T2 pulls it all. And so we got to plug all of that in when we go to do this. So then T2 will equal, we'll replace this mass with 550 kilograms times 10 meters per second squared plus, again, 550 kilograms times an acceleration of 2 meters per second squared. And so then when we do all of this math right here, we get 6,600 newtons is the tension 2 in the upper cable there. All right, now let's go and do part C here. It says if the material both cables are made from can withstand a maximum tension of 7,700 newtons before snapping, what is the maximum acceleration we're looking for the hook and mass can undergo? Also, what is the direction of the acceleration, and which cable will be the first to snap and why? I think it's actually easier to answer in reverse order here. So let's answer which is the first cable to snap and why. So it is the upper cable, and that's because it's responsible for more mass, right? It's got to pull all 550 kilograms instead of just the 500 kilograms that the lower cable pulls. Which is the direction of the acceleration? Well, that's up, and that's because when we accelerate upwards, that increases the tension. If you accelerate downwards, that decreases the tension. And if you have no acceleration, whether you're going at constant speed or sitting still, then the tension will be equal to the weight, the force of gravity. All right, so now that we got those answered, let's go in and once again, let's use our work from the previous page and plot down our equation here to solve for tension. Now this time, the difference is we know the tension and we're looking for the acceleration. So we know that that tension will break at 7,700 newtons. And so the mass here, again, be careful. This mass is the 550 kilograms, the total mass moving up. So 550 times G, I'm gonna go ahead and work that out. That's 5,500 newtons just due to the weight. And then the mass here is 550 kilograms here times the acceleration in the y direction here. So I'll subtract this over to the other side here. So we get 2,200 newtons is equal to 550 kilograms times our acceleration in the y direction, which means the last step here is that we've got to just divide each side by 550. And so, shoot, I didn't work this out beforehand. I can't do this in my head. Hey, Google, what's 2,200 divided by 550?
2,200 divided by 550 is 4.
Oh, that works out nice. Oh, shoot, yeah, duh. Because this is 500, so that will give you, and then 2,000, and then 50 times 4 gives you the 200 there. So 4 meters per second squared upwards, right? Positive is our acceleration there.